Alright, so good afternoon once again to everyone. Now, before we get back into learning about developing our pseudocode, um, I want for us to basically lay out our tasks that we have to complete for our program in SBA so that we know exactly what we have to do. And secondly, I would like to congratulate everyone that would have submitted their IPO chart, their problem statement. A majority of you did so, and it was very good. What you would have submitted, a majority of you gave some very good IPO chart and problem statements. So obviously there's some further refinements you can make. You already received your corrections, so make those as you finalize it for your SBA, and forward into making our pseudocode. So as I mentioned, I said I want to plan out or basically map what is our task that we have to complete. So so this is our program SBA tasks. So the list of tasks that we have to complete. So following our mark scheme, we have to create a pseudocode. Now before we create the pseudocode, we would have to create our IPO chart. And then we're going to make our pseudocode. So you guys are at step 1. You've already created your IPO chart. So a majority of you are almost finished with that. So that means you can go ahead and start your pseudocode. We're currently learning about how to create that. So, and I'll further explain some additional information that you need to add into your pseudocode. Now, so these are your requirements that you must have in your pseudocode. Now, after you've created your pseudocode, you need to make a trace table. So your trace table. So your IPO chart, the purpose of it is to list the input, processing, and outputs. Then the pseudocode is to, how should I phrase this? Your steps to solve the problem. What are your steps to solve the problem? Your trace table is to test the pseudocode. And what do we have to create after that? And after that, we create our Haskell program. So this is our solution. So I mentioned this in the group. Some persons were mentioning that the algorithm is the solution. No. And then some persons mentioned you create you create algorithm with a program. No, the algorithm is first, and then you get your program. I'm going to send this file later when we finish creating it, so you guys can have a copy of it. What else do we need to do? So after we've created our program, we are going to enter documentation. So you guys already started your problem statements, and inside of the program should also have documentation also. Documentation. So let me see if I missed anything. You have your pseudocode, your algorithm. These are the marks for that. You have your trace table, you have the program and the marks requirements to that. Program documentation, you need to put the author, the date. But inside of the program, for documentation, you're gonna have the author, the date, um, date created, statement of problem. We have that separated in another file there, and inline comments. So basically, you're going to have 4 documents. Think of your IPO chart and algorithm going to be as one, and then you're going to have, so this is going to be in a Word document. So here, Word documents, your IPO chart, and then your algorithm, and don't forget your test data, which is going to be a table with 10 candidate information. So your IPO chart, your algorithm, and the test data, it is going to have 10 candidates information. Your trace table is going to be in a spreadsheet, and that also is going to have the test data, the same test data. You put it inside of the another sheet so that you can see it besides the trace table also. And then you create the program, you add some documentation. These are the documentations that you're gonna have, and then we create our problem statement. So problem statement is going to include what is the issue or problem. You describe what's the issue, the problem, and what is the solution. You can add solution, and you can add a conclusion if you also want there. So that's going to be another Word document. So obviously this is going to be done in Easy Pascal. I already gave you guys that software there already, and yeah. Any questions on these steps before we move forward? Alright, so as I mentioned, these are the list of things that you have to do. It's basically 4 main components, 4 files basically you're going to be submitting. A Word document that's going to contain your IPO chart with your pseudocode and test data. So this is one Word document here. Then you're gonna have a spreadsheet that's gonna contain your trace table and test data. So when we're finished, we already finished with well, not finished, but we're still working and almost finished with your IPO chart, so you guys can start working on your pseudocode. When we're finished with that next week, we're going to start working on our trace table. And then from that now, when we finalize that, we can start working on our Pascal program. And well, you guys are already wrapping up with problem statement. So within a couple of weeks, we should be finishing up with our program in SVA if you guys work towards that. Now,
Yep. When all the SB is gonna be.
I'm not sure about that. Usually, the ministry requires it by the end of January, but I haven't heard anything as yet. So when I hear the deadline, I'll let you guys know. Alright, so I'm gonna give you guys a hint also. For your IPO chart, you should have about 3 to 4 inputs. What else? You should have, for processing, you should have at least 2 processes. And for your output, there should be about 3 to 4 output, at least 3 to 4. So for input, there should be at least 3 to 4 inputs. That these are what you should have to have the to make your program, and 2 processes and 3 to 4, at least 3 to 4 output. Those are what are necessary. What else? Well, we're currently going to start working on pseudocode. Trace tables after that. I mentioned that your problem statement, you mentioned the problem or the issue, you mentioned the solution. When you're mentioning the solution, you need to indicate how it works, and that is going to include mentioning the logical order of what is the input, what is the processing, and output. That is how you explain how your solution works. When you're explaining the issue and the problem, you mention what is the issue and the effects of that issue. How is it affecting persons? And then conclusion, you basically summarize. Alright, so IPO chart, pseudocode, test data, trace table, the program, problem statement. Yeah, I think that's about it. If no one has any questions, we're gonna continue. We're gonna move on to looking at the pseudocode for how to create that pseudocode, because we're clear on developing our IPO chart. So we need to move on to our pseudocode now. So in the last class, I would have given you guys a layout of your pseudocode, of what it should look like. I'm going to do that once again. So I'm going to add it to this document here. Let me split that there so you guys can see an example of that. It's an example on the right hand side. So pseudocode layout. I spelled pseudocode without an E. Okay. So your pseudocode layout is going to start with a title. So you're gonna have a title. You notice here, this is an example of a title there. This one indicated start, but as I mentioned last week, you don't need to indicate that start because the title indicates where it is starting from. Now after that, you have a section called variables, and you basically declare your variables. Then you're going to initialize variables. So declare basically means to name and name variable and give data type. And initializing your variable basically means to give variable a value. So after initializing, this is where you're going to start the actual code of your program. Now, you could number the initializing. So all of these initializing, if you notice, well, before I mention that, if you notice, each line of code, each line in your algorithm must be numbered. It must be given a step number. That's for you to keep track of it. And I want you guys to use the tab key on your keyboard. Don't use space. When you type in step 1, use tab so that it aligns the information with each other. Even if you want to press tab once again so that it pushes the information out like this here, use the tab key so that it aligns your information and you have a neat appearance of your pseudocode. So you're going to initialize your variables and then you're going to put your input steps, then your processing steps, and then your output steps, and then you end your algorithm, your pseudocode. So once again, ensure each step has a number. So this while step here, this line here has a step, but if you notice, this one here, even though it's in two different lines, it's being considered one step. Now why is that? This is because they're working together. They're basically working together. Now, for your program, for your algorithm, you have to take in data. So you guys should know by now from your IPO chart, you have to take in or accept, what is the data you have to take into your program? What does a person have to input?
So the candidate name.
Good. So the candidate's first name, the candidate's last name, and what else?
The votes received.
Good. And the votes
And the
cast.
votes cast.
Very good. So now when you're accepting inputs, one of the basic operations that you need to do is to give a person instruction before you accept input. You must tell a person what they have to input. So to do that, you output some text on the screen. So in this case, we output enter student first name. Let me actually run this program and show you guys. So this is the program here. I'm going to compile and then run. So notice we have the instruction here, enter student first name. Now if we did not put this instruction, we would just have this line, this cursor here that you see blinking. That is all the person would see on the screen. And the person, when they run the program, they will not know what they have to do. So that is why giving instruction is very important for them to know what they have to do. So in this case, we're going to give an instruction, enter student first name, and we type in that first name. And it's going to be read or stored into a variable called student first name. So whenever you're inputting, that is one of the key points. Whenever you're inputting, give instructions before you input. So underneath here, we can say before input, give instruction. of what to input. For storing input, give instruction of what to input. So another key point is it's not necessary to separate names, but it can be useful, especially if in certain cases you only want the person first name or you only want their last name. That is why it's more effective to separate that information. So you would usually say enter their first name, and after they finish with that, you would tell them enter their last name. So when a person enters their first name, enter, we have another instruction, enter your last name. Enter. So it stores their first name and last name. Are you guys following so far?
Yes, sir.
Yes, sir.
Yes, sir.
So that is how you design your input. You give instructions, you tell them what to input, and then you accept it into a variable. So remember, this is the variable here that was declared. I'm not sure why this algorithm doesn't declare any variables. Good, so that there is the input section. Now what you guys can actually do to make it clear on your part, you could actually say input section. So it is clear that from this point onward is for input. So you can actually put titles. So that is a part of your inline comments so that you know where you are working from. So for example, at the top here, we can say initializing variables. And even before this here, we could have said declaring variables, and we indicate what is our variable. So for example, this variable here, student underscore last name, and we're going to say equal to what data type, string, and we put a semicolon to indicate we're ending that line there. Now, so you can even bold it if you want, so that makes it more clear as you're reading it, or you can even have it indented like this here. You put the title outside here, and then you have the information indented so that you know it falls under this heading. All of that can work. So this here would be inputs. Now, so we're inputting the first name, we input the last name, we're going to input student ID. We're also going to enter the number of grade level, and we're going to input the plan. We're going to read the plan. So this is all input here. Now, so you have to make all of your input first. That's important. Notice all of our input is first. And then from this point onward is our processing. All of our calculations is going to be carried out here. So step 7, we're going to do a calculation. We're going to use the variable count students, and we're going to say count students plus 1. Now this is for the loop, so we haven't covered creating loops as yet. So we're going to look at that later on. Notice we have, we actually looked at this already. The if-then statement. So we have an example of it here. If the variable grade underscore level, if it is greater than equal to 7 and less than equal to 9, if it is true, because remember if then only looks at if it is true. If it is true, then output all of this information. You guys understand what happened there? You following?
Yes, sir.
So remember, if then, it runs a test and it only checks to see if it is true. If it is true, it outputs or it carries out whatever is a part of that true section. So all of this information here is true. So we can actually run it. Enter student ID. I'm going to make up an ID. Enter the number of the grade level. So for example, 7 for grade 7. So we're going to enter 8 so that it falls between this true section here. Because remember, 8 is greater than 7 and less than 9. And enter the payment. We're going to say 1 for full. And notice we have all of that information there from that true section. So we have student name. My name is here. Student ID. ID is here. The grade level. Grade level is here. School level. That is here. And the tuition. That is here. Now, notice it output tuition there, information, and then it outputted, it went all the way, it skipped all of this here because obviously 8 is not greater than 10, 8 is not greater than 12, so it skipped all of this step here and then went down to here. If the payment plan equal 1. So if you guys remember, I typed in 1. Look, notice the 1 here. I typed in that 1 for the payment plan. So from here is going to be carried out now. So the test is if I entered 1. Yes, I did enter 1. So all of this now is going to be carried out. So if you notice, after the tuition, payment plan is what's mentioned here. Notice it corresponds. Then we have status of the discount. Then we have discount is 10%. Then we have, well, this here is not mentioned, but this is just some processing, additional processing. It's not output. Notice it skipped payment plan equal to because that's not true. And then once again, choose one of these tests here from step number 10, one of these step number 10. So remember we entered 8. So 8 is in fact greater than 7. So it's going to carry out everything inside here. So notice it continued here. What is the discount amount? Notice we have discount amount out here. And we have tuition due. Notice we have that here also. So it skipped the rest, and then it skipped this here also because we typed in 1, and then it came down to this final part here. Output the number of students. Notice we have number of students here, and it did some calculations here, and then we have another output. Output average discounts awarded. So, and then finally we have stop here. So notice each one of these logical parts is an entire step. A combination of input instruction and storing the data is a step. Your processing, your calculation is a step. But the if could be considered one. Part of the if could be considered one. Because remember that test has to be carried out, and if it is true, everything in that test is going to be carried out. So you could consider it one step, or you could break it down into individual steps if you want also. So the rest are if statements. I notice at the very bottom we have output, some calculations being done there, more calculation. I notice each one of them is a step. So ensure you number all of your steps when you are creating it for your pseudocode. Now yours isn't going to be as complicated as this one here. It's actually some simple calculations. So I think it's basically only one if statement you're going to basically be using and a loop. So we're going to learn how to use all of that later on. Notice an example here of your test data. It's simply a table and it has the information that you're going to input. So for you guys, you're going to have that first name, last name, and the two other input, votes received and votes cast. That information is going to go in a table like this here. Alright, so are you guys following and all that?
Yes, sir.
Yes, sir.
Is there any questions that we need to clarify now?
No, sir.
Alright, so remember the steps, the layout of your pseudocode, have that title at the very top. Declare your variables, initialize your variables, and then list all of your input, then list all of your processing, and processing is basically your calculations, and then carry out your output. And remember, you can indicate your different sections so you guys can easily follow what is happening. Great, so that there once again is your layout for your pseudocode. Yeah, so I think we just covered once again what you guys should be doing for your programming. So let me find today's notes so that we can continue with that. Anyone with any questions in the meantime? All right. Give me a second. Let me close some windows. All right, I am back. So we have to continue from, I think it's example 9. Yeah, I think so. So, here. So, in review of creating a pseudocode, what have we looked at so far? So, as mentioned already, you must create your IPO chart. So you guys know how to do that. Remember, your IPO chart, you're just listing what you have to do. You list your input and you be clear as to what is the input. You list your processing, all of your calculations, you be clear as to what is going to be calculated, and you list exactly what is going to be output, the result of the addition. Now, let let's see. Alright, so I already showed you guys examples of input, processing, output, and so on. Let's see. I already showed you guys what it means to use that left arrow or the equal sign. So that there is some examples of a basic pseudocode. So this is an even more basic pseudocode. We read three numbers, we calculate, and then we output. But it's more effective to list them in their individual steps so that it's easier to follow. And then we started with conditional branching. Sequential statements, it just simply means that you're following an order, top to bottom. You're following one step after each other. That's all that simply means. So that's why we number our steps. That's why we put it in a logical order. That's why you put input before processing and then output, so that it's in that sequential order, so it follows that order logically. So then we started with conditional branching. We started with if-then. You have to remember the structure of the if-then. It has three parts. The if, it runs a test or a condition, and only if it is true will it carry out the then part. Only if it is true. So we have the example here. We're going to read three numbers. We're going to total those three numbers. Say, for example, it is 70. If total or if 70 is greater than 50, it is true. Only then will we output print total. Only then are we going to print the number total. But if it is false, there's no accommodation for false. If the total is 40, then that there is false, and it does not accommodate for false. So the program is going to end. So that there is a structure once again for if-then. The other example, example 8, we input the age is 8. Is 8 less than 13? Yes, that is true. So we're going to output the text, student is not a teenager. Once you're 8 years old, you're not a teenager. Now, what if the input was 20? 20 is not less than 13, so that is false. There's no accommodation for false. Nothing will happen if it is false. So it's going to go straight to end. Example number 9. So let's see. Okay, if then else is starting now. So example number 9, consider the following example that checks for marks of 80 or over. So we input a mark. If that mark is greater than equal to 80, then we're going to output excellent, output please see your teacher. And then we have end if. So let me give you guys two scenarios. We have 90 as our input. What is going to be our output?
Sir, excellent.
Only excellent.
And please see your teacher.
Right. So it's important to notice where the end if is located. Remember, this is only looking to see if it is true. But I think this statement, they have it incorrect. It actually should have been after this end if. because it doesn't make sense for you to see your teacher if you did well unless the teacher wants to congratulate you, unless that's the reason why. But it would have been more logical for it to be an under and if, so that if you got that low marks, you would have been able to see your teacher. But I don't think that's the purpose of seeing the teacher, for them to basically counsel you. I think it's more to congratulate, because if you notice the test mark here is 80, so I think that would be why they're seeing that person. So main fact is that 90 is greater than 80, so these two are going to be your outputs. They are a part of the then statement. Notice end is still here. So the pseudocode will output the following statements for values stored in the variable mark. So notice it's mentioned here. The value of mark 80 or greater, 86, it is greater. So we're going to see, excellent, please see your teacher. And if it is less than 80, for example 71, still see your teacher. Like I mentioned, I think this is wrong, because the end if is still at the bottom here. It's below that please see your teacher. Now notice the use of indentation in the following if then. So indentation can be important. So it helps us to follow and read the information. That was what I was explaining to you earlier. So we have our input, if mark is greater, and then these information fall on the then. This suggests that both statements will be output if the condition is true, and the variable mark contains a value greater than or equal to 80. Nothing is printed if a value is less than 80 stored inside of a variable mark. So this one here is more correct. But I'm not sure why they put it as this output here for this example, but this one here is the correct one. So if it is greater than 80, you're going to get both outputs, but if it is less, you're not going to get any output from it. So that's why it's important to indent, for you to be able to clearly follow what statement falls under what statement, basically. So it's clear that these two fall under then. Good. So once again, remember the if then statement. It only checks to see if it is true. Remember the you have to remember the layout, the structure. It only checks to see if it's true, and if it is true, it carries out the then. It does not do anything if it is false. Now that is why we have the if then else. This accommodates the false part. So if the condition is false, if the test is false, we want something to happen. So that is where the else can come into play. So the if then else statement directs the algorithm to one or more statements if the outcome of the condition is valid or true. The algorithm is directed to another set of statements if the outcome of the condition is false. So we're going to run the tests. And once again, if it is true, it's going to go to the then part. So if it is always true, it's always going to go to the then part. But if it is false, it's going to go to else and carry out that part. So then is going to have its own statements, else is going to have its own statements. And whether it's true, whether it's false, those statements are going to be carried out. So let's look at an example now. Example 10, as an example, suppose you wish to print the sum is less than 50. So you're printing a statement. Sum is less than 50. If the sum of three numbers is less than 50, but output their sum if it is greater than 50. This means you have two options. you can either print the comment or print the sum. So notice our IPO chart, we are reading three numbers, number 1, number 2, number 3, and we're going to process. We're going to calculate, we're going to add number 1, number 2, number 3, and we're going to store it into total. And then we're going to check to see if total is greater than 50. So that's our test. We're checking to see if total is greater than 50. Now, if it is true, then output total. If that test is true, output the total. What is the total? Whatever we calculated here. But if it is false, then we're going to output the statement, the sum is less than 50. Are you guys following?
Yes, sir.
Yes, sir.
All right. So in this case, we're going to use the if then else statement. So notice we have the pseudocode here now. So notice our title. This is our input. Read number 1, number 2, number 3. We have our processing here. We're going to add 1, 2, and 3 together and store it into total. We have another processing here. We are testing if total is greater than 50. If it is true, we carry out the then part, print total. But if it is false, we're going to carry out the else part, print the sum is less than 50. So let me give you guys some numbers and you will tell me what is the output. So if total is 60, is it that hard?
Pardon me, sir?
There's 60.
Is the question that hard? What's the answer? If the total is 60,
60.
Then 60.
are the rest of you in agreement or you disagree? Because I'm only hearing from 2 persons.
Agree.
Sir, 50.
Sir, yes, sir.
No, sir.
So I heard a majority of 60, so that is correct. 60 is greater than 50. So we're going to print the total and the total is 60. Now, what if the total is 40? What is going to be our output?
The sum is less than 50.
Good?
Yes, sir.
Yes, sir.
All right. So we're in agreement with that. So 40 is less than 50. So we're going to get the else output. Now, what if the total is 50? What is our answer? What is our output?
The sum is less than 50.
Okay, we have one of that answer. Anyone else? Brian, I'm muting, but I'm not hearing anything from you.
Sum is less than 50.
Nothing will show.
Nothing will show. All right. I heard somebody else said the sum is less than 50. All right, so let's look at the answer now. So remember, we're running a test, and a test usually has 2 states. It can either be true or false. When you're asking a question, when you're testing something, it's either it's true or it's false. There's nothing else to it. So it's either 50 is greater or it is not greater, either one. So that is why we have true and false here. We have then and else. So if it is true, if it is in fact greater, we carry out the true part. But if it is false, which is the other state, then we carry out the false part. So something will happen, something must happen. So 50, is 50 greater than 50?
No, sir.
No.
Sir.
50 is not greater than 50. So that means it is false. And the fact that it is false means that we're going to carry out the false part of the statement, the false part of the algorithm. Are you guys clear on that?
Yes, sir.
Sir.
All right, great. Let me see how far more. Okay, so let's look at the next example and then we're going to wrap up there. Nested condition, loops. So in the next class, we're going to look at some loops. And hopefully we look at all the loops in the next class so you guys can add that part into your SVA. Alright, so where are we? We're at example 11. So the following example also illustrates the if then else statements. Example 11, we have our title. We have our input. We have two input here. Input. So we're going to input this year. We're going to input the birth year. And then we have a processing, a calculation. We're going to subtract birth year from this year. Store it inside of age. And we're going to process, is age less than 13? And if it is true, once again, we carry out the then parts. If it is true, we carry out the then part that Millie is a teenager. And if it is false, we carry out the else part, which is Millie is not a teenager. And then we have the end if here to end our if statement. So let me give you guys two age to see if you understand what is happening here. So tell me, what is the output if the age is 15?
Millie is not a teenager.
Millie is not a teenager. Anyone else? Come on, y'all, give it a try. Is it true? The first thing you need to ask yourself, is it true or is it false? That's the first thing. Is it true or false?
False.
Another false. No one else?
Sir, false.
Another false. So it is in fact false. So the fact that you can determine that 15 is not less than 30, that is false, then that should lead you to conclude that it's going to carry out the else part. Millie is not a teenager. Now, what if the age is 6?
Millie is a teenager.
Yes, sir.
Good.
Yes, sir.
Good. So we can conclude that it is true. That's the first thing. We conclude it is true. 6 is less than 13. So once it's true, we carry out the then part of the statement. Millie is a teenager. So when you're running a test, that is how you should follow it. This is actually called tracing your program. So this is actually what you'll be doing in your trace table. So this is called tracing your program. When you follow each step, each logical step, and you say what happens. For example, you say that how this year is going to be 2022, and birth year is going to be 2000. You're tracing those two variables, and then when you say um, that 2022 minus 2000, that means age is going to equal to 22 years old. You're tracing that step there, and then when you trace 22, is it less than 13? That is false. You're tracing that step there, and then for the output now, you know that the output is Millie is not a teenager, so that there, you're tracing that step there. So that is how basically you'll be carrying out your trace table. You look at each step. That's why it's important for you to number your steps, because when you number it, you can easily follow it. You can say at step 1, this happened. At step 2, that happened. So you can also choose to output Millie's age to produce the following. So if the age is less than 13, then this is true. Then output Millie is a teen, her age is, and the variable age. So this is an example here of outputting a text and then outputting a variable to get the value. So for instance, you want to give the instruction on the screen. You want to give the output. Millie is a teenager. Her age is. Notice it's in quotation marks. And then we have a comma and the variable. So the output, so say for instance, it is 8. Our input is 8. What is going to be your output?
Millie is a teen. Her age is 8.
8. So firstly, we're going to ask the question, is it true or is it false? Yes, 8 is less than 13. So we're going to carry out the true part. Then output, Millie is a teen, her age is, and then at the very end, we have a variable. This is a variable here. Notice it's not a part of the quotation mark. So it is a variable. And when you output a variable, you don't output the name of the variable, you output what is inside of it. So the output is going to be, Millie is a teen, her age is 8. Are you guys following?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So that is how you output text, and you also output what is inside of a variable. So if you want to mention some sort of number, you can mention the variable and it mentions what is inside of the variable. So this is the structure of your if-then statement. So the general form of the if-then statement is, we have the test, the condition, and any condition, any test is always checking first to see if it is true. It's always checking first to see if it's true. When it is true, it's going to carry out the then part. But if it is false, it carries out the else part, and then we have the end. So if the condition is true, execute the true statements, do not execute false statements. And if it is false, execute the false statements and do not execute the true statements. So only one is being carried out and the other is going to be ignored. So that there is the structure of the if then else, and this part here is also important because when you guys have to output in your SBA, in your program, you're going to need to give some instructions and then output the value of a variable. For example, when you have to output how much persons have a discount, have a refund. So you can say total persons or total candidates with a refund equal, and then you put the name of the variable. So all of this is going to be in quotation marks, comma, variable. So it's going to output this instruction here on the screen, and then output what you are counting inside of that variable. How much persons got a refund. Are you guys clear on that?
Yes, sir.
Yes, sir.
All right. So once again, we just wrapped up on conditional statements. So it's important for you to remember the two conditional statements we have. We have if then. We check to see if it's true, carries out the true part, but it does not do the false part. It has nothing to do with false. Only the if then else has a false part, and then it considers the false part. So if it is true, it carries out the then part. If it is false, it carries out the else part. So next week, we're going to look at nested conditions. We're going to look at creating loops inside of our algorithm, inside of our pseudocode. So you guys can get started now on using your input, your processing, your output. And when we get into the loop part, we're going to look at how we can incorporate the loop into your pseudocode. Any questions before we end?
No, sir.
No, sir.
All right. Well, if you guys don't have any questions, that is going to be the end of today's class. Enjoy the rest of your day.
You too, sir.